in this video we're going to look at organic chemistry, and we're specifically going to look at elimination, oxidation and reduction, and polymerization reactions. So our learning intentions are to explore redox reactions, including their mechanisms and the chemistry behind them. We're going to explore polymerization reactions as well as elimination reactions. So first we're going to look at elimination reactions. This is only a small section of our organic chemistry, so we'll only briefly touch on it. And it's always key to start off with a definition. So an elimination reaction is one in which a small molecule is removed from a larger molecule to leave a double bond in the larger molecule. So that basically means one of the products of your elimination reaction will have a double bond. Now, an example of an elimination reaction is the dehydration of ethanol to form ethene, and we met this in our fuels videos already. The elimination reaction is the reverse of the addition reaction that we've already spoken about in this topic. And finally, the formation of propene from propan-2-ol is another example of an elimination reaction. So next we're going to look at oxidation reduction reactions, and these are often referred to as redox. And as we know from our oxidation reduction videos on the website, that we have oil rig, where oxidation is loss and reduction is gain. And what we're going to be looking at is we're going to be looking at the oxidation and reduction of alcohols, aldehydes, carboxylic acids and ketones. So when a primary alcohol reacts with an oxidizing agent, it is converted to an aldehyde. Now, suitable oxidizing agents for this reaction include sodium dichromate and acidified potassium permanganate. And if your oxidizing agent is added in excess, the aldehyde will then furthermore be oxidized to a carboxylic acid. So let's look at this now in a little bit more detail. So I've drawn out a kind of mechanism scheme here for you to see what we mean. So a primary alcohol, first of all, you remember what a primary alcohol is from our organic families chapter, and that is that a primary alcohol is one where the carbon atom joined to the OH group is attached to one other carbon atom. So that means this R group here will be a carbon atom. Now, we know that our primary alcohol will go to an aldehyde during an oxidation reaction. And we can easily see that the conversion of the primary alcohol to an aldehyde is an oxidation reaction, and we know that because two hydrogen atoms are removed. And if you remember back in our oxidation reduction chapter, we explained that reduction is the addition of hydrogen. So if reduction is the addition, that must mean oxidation is the removal, because they are opposites. So then we form an aldehyde. And the word aldehyde comes from the term alcohol dehydrogenation. And then, as we can see here down the bottom, if we do have excess of our oxidizing agent, so for example sodium dichromate, we can see that the aldehyde will convert to the carboxylic acid. And this is very clearly an oxidation reaction, because you can see we are gaining an oxygen here on one of our carbons. Now, if we have a secondary alcohol, it can be oxidized by the same oxidizing agent to a ketone. However, the ketones themselves are quite difficult to oxidize, but they can be easily reduced. So once we reach our ketone, we're not going to really oxidize any further. So as we know, if oxidation is occurring, obviously reduction must also be occurring. So aldehydes and ketones can be reduced back to alcohols in the presence of hydrogen and a nickel catalyst. Aldehydes will usually be reduced to primary alcohols, while ketones will usually be reduced to secondary alcohols. And it's important to remember here that the aldehydes reduce to the primary alcohols, but if it's a carboxylic acid, the carboxylic acid will also reduce to an aldehyde first. So to show this in greater detail, I kind of drew it out as a little flow chart for you. So here we can see we have our carboxylic acid, ethanoic acid, and our carboxylic acid is reduced back to our aldehyde, which is ethanal, in the presence of our hydrogen and nickel catalyst. And if hydrogen gas and the nickel catalyst are present in excess, that ethanal will then go to ethanol consequently. Now, ethanol is oxidized to ethanal to get rid of it from the body, and this takes place in the liver. So this is a very good example of oxidation and reduction happening in real life. The ethanol, or the alcohol that we absorb into our system from socializing, gets oxidized to ethanol in the body to get rid of it, and this takes place in the liver. Ethanol can be obtained from sugarcane and is used in petrol in Brazil, but not in Ireland due to it being so expensive. So all organic compounds burn to form carbon dioxide and water, and we know that because all combustion reactions form carbon dioxide and water. So here we can see that we have the combustion of our ethanol as a fuel, and it gives off carbon dioxide and water. So to finish off, we're going to look at polymerization reactions, and it is possible for molecules containing double bonds to undergo addition reactions among themselves. So they must have a double bond. So a definition of a polymer: polymers are long chains of molecules that are made by joining together smaller molecules. They consist of a repeating unit. An example of this is polythene, as I've shown down here. We can see our ethene molecules undergo a polymerization reaction, so they all have the double bond to form polythene. So the small molecules from which a polymer is made of are called monomers, and polymers are commonly referred to as plastics. So polythene is a form of plastic. So another example of a polymer is polychloroethene, and this is actually PVC that you may have heard of in Windows, and it's gotten from reacting chloroethene molecules. Another useful polymer is polypropylene, and it's used in the manufacturing of plastic beakers. Now, we've said that a polymerization reaction involves a repeating unit. So the repeating unit of a polymer is the part of the polymer whose repetition produces the complete polymer chain, except for the end groups. So polymers of polythene and polypropylene are called addition polymers, as their production involves addition reactions. So just to finish up, we're going to look at hydrogenation of vegetables. So the hydrogenation of a C-double-C bond in a molecule is often used in the production of margarine. Now, in general, animal fats are usually saturated, but vegetable oils are unsaturated. But we know that edible oils do not spread well. So scientists actually found that by adding hydrogen to the C-double bond C in oils, that it changed them into soft solids with low melting points. So this means that margarine is actually better to spread than butter, but it's also healthier. So that's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.